In this video, I am going to show you how to find the centroid of a simple and the centroid of a complex shape. What this means is that if I had a simple shape cut out in a piece of paper, whether it's a triangle, circle, square, rectangle, I'm going to show you how to find that center of balance or the balancing point. So if I were to take a pencil and put that paper on the tip of the pencil, if the tip and centroid of that shape are matching up, then that means the shape would be balanced on top of the pencil. By complex shape, I mean taking the simple shapes, putting them all together to form a weird, complex shape. So to find the centroid of this rectangle, we need to know the length of the two dimensions. We need to know how long the base is, as well as we need to know how long the height is. And in order to find that, we're going to take the base divided by the 2 and the height divide that by 2. Right? This is an ordered pair denoted as x bar, y bar. And this here tells us the location of the centroid of this rectangle, which the shape denoted by this datum point. A semicircle is half a circle. In a circle, full circle, right, the radius, or the center of the circle is usually the center of mass. But because we have half a circle, that does not mean that this is still the center of mass. We know that this part is still the radius. This part is still the radius, right? So in this case, for this centroid, we are using r for the radius. That centroid is approximate up here. And in order to find this height, we take 4 times the radius divided by 3 pi. Right, that is that much higher, 4r over 3 pi, above the center of a full circle. Not all the cases are going to have this type of semicircles, but we're also going to have turn the other way around. If this is the center, and this is the radius, this is a radius, this is now under the y direction, so that means that this centroid, I'm still using the same numbers or the same formulas. Now they've kind of interchanged. 4r divided by 3 pi is going to be this x distance, and this y distance is the radius. Alright, here we have a right triangle. Alright, in order to find the centroid of that right triangle, right, that one is base divided by 3 over the height divided by 3. Okay, so that means that this is my base, this is my height, so that means that the centroid is somewhere right here. Alright, we want to be careful because this base and that height are the ones that do form the 90 degree, right? So that means the centroid is base over 3, height over 3, away from the right angle. Away from the right angle. So that means that here we have the height over 3, and this is the base over 3. Alright, so quick recap to find the centroids of these 3 individual shapes. Now we have a coordinate grid. Here we have our x-axis, and up here is our y-axis. Again, 3 individual shapes. I'm going to find 3 centroids. Right? I need to know the length of my base of this rectangle. 1, 2, 3, 4 units. 1, 2, 3 units for my rectangle. So that means that I'm going to take the base, divide that by 2, and the height, divide that by 2. My base is 4. My height is 3. So this comes out to be 2, 1.5. Right, this is true in length, but because now we are in a coordinate grid, we want to know what is this coordinate of the centroid. We know that it's 2 units here, which is right here, and 1.5, which is here, right? Because this is 3. So that means that the actual ordered pair for this is -2, 1.5. For the right triangle, again, I need to know the base and the height. The height is still 3 because it's shared with this rectangle. And then the base is 1, 2, 3, 4 units as well. Again, to find the xy of that, I take the base divided by 3, and I take the height divided by 3. Which comes out to be this right here. Okay, so 1 1/3 and 1, which comes out to be somewhere right here. Again, it's the distance away from the right angle, but because the right angle begins at 0, 0, this still matches these values. Last but not least, we have the circle. It is right cut off the top part, so the center would have been right here. So that means that my radius is 2 units long, which is also right. Radius is equal to 2. Right, so this center part right here, it's not going to end up matching from what we had earlier with centroids, right, at r comma 4 pi over 2. This center is located directly at 0, so I'm going to start off with 0 for my center in the x-axis, because the overall is right here, 4 times the radius divided by 3 pi. So I need to substitute in numbers. 4 times 2 divided by 3 pi. If you're going to do this in a calculator, please make sure that you do use parentheses. 4 times 2, divide that by 3 times pi. When you do that, we end up getting this right here. Right, I'm just gonna round to the nearest thousandth. So in this case, it would be 0, 0.849 for that centroid right there. in order for us to find the centroid of a complex shape, we need to know areas of these simple shapes. Area of a square is side times side, or side squared. Area of a rectangle is the width times the height. Here's the width, here's the height. The width is also can be referred to as the base. Area of a full circle is pi times r squared. R is the distance from the center to the very edge of the circle. Area of a right triangle, or any triangle I should say, is 1/2 times the length of the base times the length of the height. My preferred method of teaching centroids of complex shapes breaks down into these 9 steps. Steps 5, 6, 7, 8, and 9, the reason why they are in blue is because they are in the table which organizes our work and makes our work a lot easier than it's originally intended to. The first thing we want to do is actually break down into simple shapes. So you have this weird shape and break it down as most as you can to a rectangle, square, circle, or semicircles. Once you break down into those simple shapes, you're going to calculate the centroid of each of those simple shapes. Step 3 is now that you're going to locate a coordinate of each of those centroids. Find the actual xy in a coordinate plane on the xy axis. If there are no xy axis, the best thing to do would be to put the bottom left part of your centroid of your complex shape, I should say, be the 0, 0, and then create an xy off of that. That makes 3 somewhat easier depending on how your shape is. Step 4, we want to know the area of each of those shapes. This should be shape, not centroid. Calculate the area of each simple shape. Once you have this, these numbers are going to go into a table which makes 5, 6, 7, and 8, and 9 very, very easy. We're going to multiply the x-coordinate of step 3 with step 4 of the area of each simple shape. After that, we're going to add all those products to get step 6. Step 7, just take the areas and add them all together. Step 8, we are going to take the result of step 6 and divide it by step 7. That result is the overall x-coordinate of the complex shape. Step 9, we do the same thing, but instead of using the x, we are going to use the y numbers for in step 5, right? And then we have our y coordinate for the complex shapes once we follow through with 5, 6, 7, and 8. With this one, there are possible negative areas or removable areas. Alright, so that means that I cut a shape off of the area, and I'm going to show that in the example we're about to do. Alright, so we're going to calculate the centroid of this complex shape. Okay, again, first thing to do, we're going to break this down into easier shapes to deal with. Alright, so what I'm going to do is I'm going to do this. That way I have this right triangle as my first shape, this second right triangle as my second simple shape. I'm going to use the square as my third simple shape, and then I'm going to take 4 of this whole that is made up of this circle. All right, we want to clarify a couple of things, right? This is 3. This is 3 from here to here, and then from here to this here, it's also 3. Here's my y-axis, and here's my x-axis. All right, so here's my 0, 0 right there. All right, so we're given that, so we don't need to create that. What we have missing here, though, is the radius is 2. Okay? I think I just put an overall. Yeah, there it is. Yeah, 2 inches. So if this is 2 inches from here to here, then that means that from here to here, that's 1 inch. Here to here, it's also 1 inch. Here's a different way I represent inches. How tall is the square? 3 plus 3 is 6. Plus another 3 is 9. So that means that this height of this right triangle is 9 inches long. I want to clarify that because, again, this is shape 2, shape 1, shape 3, and shape 4. I don't want us to confuse this 2 is this base right here of 6 inches. Alright, now that I've broken them down, let's break this down into the other ones. Alright, we want to know the centroid of this right triangle. This is a right triangle, so base, divide that by 3. Height, divide that by 3. My base is 6. My height is 9. 6 divided by 3 is 2. 9 divided by 3 is 3. Right, so what that means, here's my right triangle. Here's my base, so 2 units is going to be my centroid. And then this is 3 units right here. The most difficult part that students have to understand this is that they say that this location is at 2, 3. They automatically take these right here. But in reality, they are incorrect because it is this right here. This is 2, but this height is not 3 based on the ordered pair. Alright, this is actually 9, because that's the total height, minus 3, which is 6. So in this case, this ordered pair is 2, 6. Alright, we're going to make things easier as well. We're going to find the area of that right triangle. 1/2 times the base, which is 6, times the height, which is 9. 6 times 9 is 54. Times 1/2, so the area is equal to 27 units squared. Keep this one in mind right here, and these two xy's. Okay? Next simple shape. Use my right angle. Again, base, divide that by 3. Height, divide that by 3. The base is 6. The height is 3. So this reduces to 2, 1. And this is not the location of this centroid here. Again, a lot of students make that mistake saying that this is 2, 1, right? Because 2, 1 is actually somewhere right there. This 2, 1 means that the base from the 90-degree angle, 2 units this way, 1 unit up here. So this ordered pair was, again, we said that this height was 6, plus 1 more is 7. So that's 7 for the height. Since it's a 0 and 2 units to the left of the y-axis, negative 2, 7 is the xy. Area of that triangle, again, is 1/2 times the base, which is 6, times the height, which is 3. 6 times 3 is 18. Area is equal to 9 units squared. Or in this case, 9 inches squared. Let me go back and fix the other one. Inches squared. Again, this is the number we want to keep in mind. The xy's. Here are the x and y's that we want to keep in mind, and the area we want to keep in mind. We're going to use those to fill out our table once we get to the table for steps 5, 6, 7, 8, and 9. Next simple shape. Square. Right? The centroid is base divided by 2. Height divided by 2. Not 3, 2. I was already jumping ahead. 6 divided by 2 is 3, 3. Alright, so again, that means from the base, right, since the 6, cut it in half. And then cut that in half, so it's right here. But the overall, right, is in the xy. Since this is on the left side of the x-axis, this is negative 3, comma 3. The area of this, base times height, or side squared, area is equal to 36 inches squared. Our last simple shape is a circle. We know that the radius is 2, right? In a circle, here is the centroid, or the center of the circle, right? We know that, again, that this is 2, and this distance right here was 1. This is 2, and then from here to here, it's 1. So again, there is no formula defining the location of this centroid of an overall circle. We just need to use some knowledge based on geometry, right? So on the left side, right, 1 plus 2 is 3. The height is 2 plus 1, which is also 3. But again, left side, or the negative side of x-axis, the centroid is at negative 3, comma 3. So it is in the same place as the back here. Okay, let me make this a little bit better to see. All right, and I'm using red here as opposed to the blue in the other one because, again, this was a removable area. We are going to remove it. In this case, in the table, since we are removing area, this area is going to represent as a negative value. So area of a circle is equal to pi r squared, which is pi times 2 times 2. So the area is about 12.56637,061. Alright, so for this I am going to only use to the thousandths place. So I'm going to be using this number, 12.566 inches squared. Here's what we want to keep in mind, and this order pair as well. Right, now moving on to the table, the more easier parts. Again, this is going to be the hardest part, finding the ordered pairs. Alright, we had said this is shape 1, 2, 3, and 4. This means the x location of the centroid of shape 1, area of shape 1, and this is we're going to multiply the centroid and the area over here. Right? Again, this is the beginning of step 5, which is multiply the x coordinate of step 3 and step 4, the area and the coordinate, right? That's what we're going to end up doing for each shape. So we're going to multiply all this to get these numbers. So that was step 5. Step 6, add everything here. Step 7, add everything here. Step 8, divide this to this. And in step 9, do this, but instead of using X numbers, we're going to use Y numbers. All right, so in shape 1, right, the centroid was at 2, 6. So this 2 goes right here. The centroid to shape 2, that was at -2, 7. So -2 is here. -3 and -3 right there at the center. Area of shape 1 was 27 inches squared. I am not going to care about areas right now. I'm just using numbers. Alright, I'm going to show you how they all are going to end up getting to this one over here. So this is inches squared. Alright, when I multiply 2 times 27, I get 54 inches to the third power. Inches squared and inches to the first is inches to the third. In a way, it's sort of kind of like volume, but we're not multiplying by the third dimension. This is something slightly different in terms of numbers, but units very similar. Shape 2 was the other right triangle. That area was 9 inches squared. -2 times -9 is -18. Yes, it is possible for us to get negatives in here. -3 times 36, that is -108. And -3 times negative 3 times -12.566, that is equal to -37.698. That was step 5, multiply from left to right. We're going to add all these three numbers. That is step 6, 54 plus -18 plus -108 plus -37.698. This is -34.302 inches to the third power. We're adding lengths, which is this here. We're going to add areas. This is the next step. This is step 7. 27 plus 9 plus 36 plus -12.566. That is 59.434 inches squared. That's step 7. Add all the 4 areas. Step 8. Take this and divide it by that. That is -0.57714. Inches to the third divided by inches squared is inches. So the x centroid of this complex shape of one right triangle, a second smaller right triangle, shape 3 being a square, and we cut a hole on that, is -0.577 units away from the x-axis. So it's somewhere in between right here, almost in the center, right? Because we said that this distance was 1. This is the x. This was step 8. Step 9 would be to repeat all this again, but instead of using x, we're using y's. So the y to this was 6. The y to this one is 7, right? 6, 7, and then these were positive 3 since everything's on the positive side of the y-axis. The beauty part about this, I forgot this multiplication, right, is that these areas are the same. So this is going to be the same for the next table. 27, 9, 36, negative 12.566, and then this is 59.434. So in a way you're done here. All you gotta do is just multiply straight across and then add, take this result, divide it by that. 6 times 27, 162. 9 times 7 is 63. 36 times 3, 108. Negative 12.566 times 3. Same one, right? But 37.698. Positive times negative is negative. Combine all these. 162 plus 63 plus 108 plus negative 0.698 of negative 37, right? We get to 295.302. So the y coordinate of the centroid of this shape is 295.302. Divide that by 59.434. And we get 4.968570179. So the y equals to 4.969 if I'm running off to nearest thousandth. Right? So the overall centroid of this complex shape equals negative 0.577, comma 4.969. This was 6, here's about 1, so it is about right there. So if I cut this shape out and I put a pencil right and try to bounce it roughly around this right here, right, then this means that this shape will be bouncing on top of the paper. And that is to find the centroid of a two-dimensional complex shape.